They found it on a Tuesday. The notification arrived without fanfare, a simple string of alphanumeric code blinking on a monitor. The room was quiet, filled with the low hum of servers. It had a designation, New 31. The data packet originated from the Atlas network, our planet's automated sentry. In that moment, it was just another detection among thousands. Another faint speck of light moved against a backdrop of distant, unmoving stars. But as the automated software stitched together its trajectory from initial observations, a flag was raised. A digital hand shot up in the dark, demanding human attention. The room, once routine, fell into a heavy, expectant hush. This story is not one of panic, but of process. It is the story of how a single cold file can ripple through the scientific community. New 31 was not discovered with a shout, but with the soft click of a mouse as an astronomer pulled up its orbital plot. The initial path was alarming. The calculations were preliminary, riddled with the wide error bars of any new discovery. Yet even with that uncertainty, the projected path intersected Earth's orbit in a statistically significant way. The computers flagged it. The scientists looked. This film intends to tell a simple factual story about that discovery. To understand the significance of New 31, one must first understand what ATLAS is. The name stands for Asteroid Terrestrial Impact Last Alert System. Think of it not as a single giant telescope, but as a team of robotic eyes distributed across the globe, Hawaii, Chile, South Africa. Their mission is singular and stark, to scan the entire visible sky every single night. They are designed to find moving objects, asteroids, comets, that might pose a threat to Earth. ATLAS is our planetary burglar alarm. It is not built to take pretty pictures of distant galaxies, but to detect motion, speed, and direction, providing precious warning time of an impending impact. It is a system built on the sober acknowledgement that the solar system is a busy and sometimes dangerous place. Its telescopes take hundreds of exposures each night, and powerful software compares these images, looking for anything that has moved. A new dot of light that appears where none was before, or a known dot that has shifted position, is immediately flagged. The system automatically calculates the object's preliminary orbit, its speed, and its brightness. This is how New 31 was born, pixels forming a coherent vector across a digital sensor, a faint fast mover on a path uncomfortably close to Earth. The system's true power, a last alert, designed to trigger immediate urgent follow-up from a global community. The data itself was a cascade of cold, hard numbers, but their meaning was deeply emotional. The first key metric was the object's MOID, or minimum orbit intersection distance. This is where the asteroid's orbit comes closest to Earth's. For New 31, this distance was exceptionally small, well within the threshold of a potentially hazardous asteroid. It meant that, at some future point, asteroid and planet could occupy the same point in space at the same time. This number alone is not a guarantee of impact, but it is the necessary first condition. The second critical set, estimated size and velocity. Based on brightness, New 31 was estimated between 80 and 250 meters in diameter. At tens of thousands of kilometers per hour, its kinetic energy rivaled many nuclear weapons, far larger than the Chelyabinsk meteor, which shattered windows and injured over 1,000. The third, unnerving result was timing, months, not decades. Projected close approach in early 2026. A short timeline limits options. The uncertainty cone shrank, and Earth stayed inside it. Impact probability stayed low, but refused to drop to zero. Close pass, significant size, near-term window, the trifecta of planetary defense nightmares. Worldwide observations fed the models, but the statistical ghost lingered. The possibility of an impact was real. When NASA officials and planetary defense experts speak of what they fear most, it is not the giant dinosaur-killing asteroid we see in movies. Those are easier to spot. The true fear is the sudden appearance of a small or medium object on a direct course with little warning. A cosmic surprise attack emerging from darkness. Our best tools, kinetic impactors or gravity tractors, require years or decades. Design, build, launch, then travel across the solar system to intercept. With months on the clock, those options are off the table. We shift from deflection to civil defense, evacuation, shelter, bracing for the aftermath. Gaps exist, approaches from the sun's glare, unusual orbits, or late discovery. New 31 was a stress test of the global warning system. Fear extended beyond the rock to societal chaos. The terror of having knowledge without tools to prevent it. Not just another asteroid, a live fire drill for our worst-case scenario. Potential regional devastation, near-term arrival, forcing ground-based mitigation. A chilling reminder how easily it could become reality. This is why the initial data was met with such gravity. It was not just fear, it was preparation. In crisis, the world looks to NASA for guidance and reassurance. After a brief acknowledgement, briefings slowed. Official channels went quiet. Silence is not secrecy, it is responsibility. Early data is uncertain. The cone of possible futures is wide. They gathered photons, ran thousands of simulations, coordinated globally. Behind closed doors, the hum of intense focus. Silence allows agencies to align plans and messaging. The calm before a potential storm. Section 6. Deconstructing the risk, trajectory, size, and uncertainty. First, trajectory. A threat only if paths intersect. Orbits are probability clouds that shrink with observations. Second, size. 80 to 250 meters. City to regional devastation. Third, uncertainty. 1 in 1,000 means confidence bounds, not destiny. Nightmare is the latter. 1 in 1,000, 1 in 100, 1 in 10. Risk. Aus, trajectory, X size, X uncertainty. New 31 scored high on all three. Scientists raced to collapse the cone and decide false alarm or genuine crisis. The possibility of an impact was real. Section 7. From airbursts to ocean impacts. Most likely, ocean impact. 70% of Earth is water. Not a harmless splash, steam explosion, and potentially significant tsunami. Coasts hundreds, even thousands of kilometers away could flood. Airburst, fragmentation and a blinding flash, followed by a crushing shockwave. Least likely, most devastating. A direct land strike. Kilometer-scale crater, widespread destruction. Section 8. Between hope and preparation. Hope. Acquired data to rule out impact. Astronomers coordinate worldwide. Preparation. Emergency agencies assume impact remains possible. Risk maps, evacuation planning. With months of warning, the largest civil defense operation in history. We have frameworks, IAON for data sharing, SMPAG for mission planning advice. New 31 showed we are not helpless. We can see, calculate, and plan. Section 9. A vigil under the stars. Astronomers in domes, analysts at screens, a world holding its breath. Night by night, the probability cloud shrinks. Then a binary answer, a clean miss, or a confirmed impact. Respect the sky, support the science, work together, be ready.